happens if I start applying some force on this glass? So weird. If I'm applying little amount of force, this glass won't move. If I start to increase this force, again this is not moving.
ज़्यादा ही दिमाग खराब है.
I'm increasing the force by small amounts. So what is that thing that is opposing the motion of this glass with respect to this register? इसके बारे में हम बात कर रहे हैं. But now you apply a sufficient amount of force, then I can see that this glass is moving.
क्या समझ आया?
So here I would like to tell you about two types of friction. One is static and other is kinetic. Static, as the name suggests, is static. So what comes to your mind when you say static? A person is standing. Kinetic, person is on kinetic, is moving. Okay, in the first case, when I was trying to push this glass, when I was applying small amount of force and I could not observe any relative motion of this glass with respect to the resistor, which force was opposing the force that I was applying? Which force was that? It was the static friction. Now, I also said that I tried to gradually increase the amount of the force so that this glass may move. But then also I could not observe any relative motion of this glass with respect to this resistor. What do we conclude here? The static frictional force is a kind of self-adjusting force. It adjusts itself according to the situations. Just like the matrimonials wherein you write that the girl is very adjustable. Whatever situations you give me, I'll adjust. I'm cool, I'm good, I'm sanskari. Matchmaking process. So you need to understand that the static frictional force does not exist by itself. अगर आप उसे चुनौती नहीं दोगे, वो नहीं आएगी. But in this case, you applied. What you did was you tried to apply a force in this direction, in this horizontal direction, or at some angle, say this. You tried to move this glass. Up till here it was good, it wasn't there. The static friction is out of sync. यहाँ तक सब कुछ ठीक था, but जैसे ही the moment you start applying a force here, this force comes into picture, this force appears into the scene, adapts to the situations. But you know कि हर एक इंसान की adjust करने की कोई capacity होती है. वहाँ तक वो कर लेगा. उसके बाद भी अगर तुम बाज नहीं आ रहे तो वो कैसे फिर कंट्रोल करेगा उसे? हर एक इंसान का एक स्टैमिना होता है कुछ एडजस्ट करने का. ये सेल्फ एडजस्टिंग तो है, बट इट इज हैविंग सम मैक्सिमम अमाउंट ऑफ वैल्यू, जिसके बाद ये हाथ ऊपर खड़े कर देती है. उसके बाद ये कह देती है अब काइनेटिक फ्रिक्शन का काम मेरा हो गया, अब कोई और देखे. सो बेसिकली यू नो दैट व्हेन देयर इज नो अप्लाइड फोर्स देयर इज नो स्टैटिक फ्रिक्शन एंड इट कम्स इनटू प्ले द मोमेंट देयर इज सम अप्लाइड फोर्स. और जैसे ही द अप्लाइड फोर्स इंक्रीजेस, स्टैटिक फ्रिक्शनल फोर्स आल्सो इंक्रीजेस, बट एक समय के बाद उसका बांध टूट जाता है. ठीक है? So what is this static friction doing? It opposes impending motion. Now what do you understand by the term impending? Impending motion is something that is about to happen. It hasn't occurred yet. Note that the motion hasn't occurred yet, but it is about to happen. But it is about to happen. कि मतलब तूफान से पहले की खामोशी. तूफान आएगा, you know that तूफान will आएगा, you know that the disaster is about to come. जो सारी situations है आपको पता है वो होने वाला है, but still that disaster hasn't occurred. This is impending motion. Impending motion मतलब होने वाला है, हुआ नहीं. होगा पक्का, जो हरकतें हो रही हैं होगा ज़रूर, but होने वाला है, अभी तक नहीं हुआ. This is impending motion. It means impending motion is the motion that would take place if the frictional force would have been absent, but the motion is not taking place. Why? Because some frictional force is there which is static in nature. The static self-adjusting frictional force is acting and it is preventing the relative motion of the two bodies. Had this frictional force been absent, this motion would have definitely happened. So I was talking about there is a maximum limit. एक maximum limit है किसी को दिमागी प्रताड़ना देने की. Okay, so there is a maximum limit to everything. There is a maximum limit to everything. So similarly, there is a maximum limit to the static friction, which is mu s times n. This s is in the subscript. Mu s is the coefficient of static friction. And this n is nothing but the normal reaction force. I told you about the contact forces. They had the components in the normal and the parallel direction to the surfaces in contact. तो जो normal direction में था, perpendicular direction में, that was the normal reaction force, and it is this normal force that is appearing in this expression for the maximum amount of static friction that is allowed. तो maximum static friction क्या हुई? And you need to know this, that this coefficient of static friction, this only depends upon the type of surfaces that are in contact, and it is not depending upon the area, surface area. Like इसका surface area ये है, उतना ही surface area नीचे से ये contact में इसके आ रहा है, तो इनके surface area of the two bodies, इसके ऊपर this is not dependent. This frictional force is independent of the areas in contact. But ये glass किस material का बना है, and the surface on which this glass is kept, the material of these two bodies in contact, this mu depends upon that. I mean to say that this glass is having some mass. If I change the shape of this glass, if I design some new glass having some fancy shape, तो इस frictional force को कोई भेदभाव नहीं है. वो कहता है आत्मा वही है, रूप अलग ले लिए हैं बॉडी ने, है तो चीज़ वही ना, वही मास का है, उसी मीडियम से बनी है. So some things have been found experimentally. Experimentally, what things have been found? So experimentally, it is found that the limiting value of the static friction is Fs max, which is approximately equal to mu s times n, the coefficient of static friction, into the normal force, normal reaction force. So that means that the static friction is always less than and equal to mu s times n. Equal in the case when limiting case है, limiting case of impending motion. And whenever this is less than this mu s times n, in that case there will be no relative motion of the two objects. However, the second case wherein this glass was moving on this resistor, the applied force, if it is increased by this maximum amount of static friction, अगर मैं external force को बढ़ा दूंगी इस Fs max से, तो क्या होगा? Let us suppose that 12 Newton was the maximum amount of force that this force of static friction could oppose, and I am applying an external force of 15 Newtons now. In that case, what happens is that relative motion will occur between the two objects. Now first, the frictional force, after reaching its maximum limiting value of static friction, this will suddenly decrease, and then a force of constant magnitude will start to act. So frictional force decreases from this static maximum value Fs max, इससे कम होके फिर एक कांस्टेंट वैल्यू की तरफ चल पड़ेगी. फिर वो भी क्या कहेगी कि रोक तो मैं भी इतना ही सकती हूँ, कि भी कोई वैल्यू होगी वो भी उतना ही कुछ रोक सकती है, लेकिन तुम अगर हट ही नहीं रहे हो, मैं अपना एक्ट करती जाऊंगी, तुम अपना फोर्स अप्लाई करते जाओ, तो काइनेटिक फ्रिक्शन एक कांस्टेंट वैल्यू की आ जाएगी, एंड दिस विल स्टार्ट एक्टिंग. सो लाइक स्टैटिक फ्रिक्शन, इसको भी एरिया ऑफ कॉन्टैक्ट से कोई फर्क नहीं पड़ता. फर्दर, दिस काइनेटिक फ्रिक्शन इज ऑल्सो इंडिपेंडेंट ऑफ वेलोसिटी. इट सेटिस्फाइज अ लॉ दैट इज सिमिलर टू द स्टैटिक फ्रिक्शन. इसकी भी वैल्यू क्या है? म्यू टाइम्स एन है, बट ये म्यू क्या है? इसके सबस्क्रिप्ट में क्या होगा? K. This is mu K times n. This mu K is the coefficient of kinetic friction. अब मैंने कहा था फ्रिक्शन कुछ वैल्यू से डिक्रीज हो जाएगी जब रिलेटिव मोशन होना स्टार्ट होगा. दिस मैक्सिमम स्टैटिक फ्रिक्शन ड्रॉप्स, फ्रिक्शन डिक्रीजेज सडनली, एंड देन द रिलेटिव मोशन स्टार्ट्स. ठीक है. So this means that the coefficient of kinetic friction is always less than the coefficient of static friction. ये भी experimentally verified है. This has been observed experimentally. So if you have a force F here, external force F here, so which is trying to move the glass in this direction, the frictional force will oppose this relative motion, and this will act in this direction. The frictional force will act in this direction. तो kinetic friction act करेगी mu k times n. So F minus this kinetic friction divided by the mass of this glass of water will be the acceleration of this glass. Now you know the case of uniform motion is when the acceleration is 0. So that will be the case when the external force is equal to the force of kinetic friction. You can also note one thing, that the moment you stop applying this external force, the only force left will be the force of friction, the force of kinetic friction. So ultimately you see that a moving object ultimately stops, because in the absence of sufficient amount of external force on this object that is moving, the frictional force that is meant to oppose the relative motion will obviously act, and it is this frictional force which brings the object to rest, after some time. So these laws of friction do not have the status of the fundamental laws like other forces, like those for gravitational, electric and magnetic forces. इस तरह का फंडामेंटल स्टेटस नहीं है. तो ये क्या है, जस्ट एम्पिरिकल लॉज हैं. तो एम्पिरिकल इज समथिंग दैट इज बेस्ड ऑन एक्सपेरिमेंट्स और प्रैक्टिकल एक्सपीरियंसेस rather than on ideas or theories. Empirical laws are capable of being verified experimentally. That means कि experiments ही उन्हें support करते हैं और उनको experiments ही गलत prove कर सकते हैं. Empirical laws can be proved wrong by the experiments itself. वही उनको support करते हैं, वही against अगर उनके जाए the experiments और observations, वही उन्हें disprove कर सकते हैं. So these laws of friction are only empirical relations that are approximately true, yet they are very useful in mechanics when you solve your problems. So now you know that when the two bodies are in contact, each of the two bodies will experience a force due to the other body. Frictional force is the component of the contact force which is parallel to the surfaces in contact and which opposes the impending for the case of static friction or the actual relative motion for the case of kinetic friction between the two surfaces. Now, if you have watched the entire video, you must have observed that I used the term relative motion. Friction opposes relative motion and not the actual motion. In fact, friction is responsible for motion in some cases. The job of this force is to only oppose the relative motion. So it's not motion, but it is the relative motion that friction opposes. I give you an example. Now consider a box which is lying in the compartment of the train, and the train is accelerating. Now concentrate on the box which is kept in this train. So the only forces that are acting are the normal force and the gravitational force, as you can see. Now the third force that seems to be acting here is the force of friction, which is between the bottom of this train and the lower surface of this box. So this force of friction, which is the static friction at this moment, it is actually responsible for carrying this box along with this train, along with this accelerating train. Had this frictional force not been present, so what would have been the case? क्या होता? ये मान लो box है. Box is accelerating with the train. The only conceivable force in this case is the force of friction. Now, in the absence of the force of friction, क्या होता? This box would have been there. The box would have remained in the position where it is because of the inertia, and the floor of the train, this would have moved. And this box would ultimately hit the backside of the train. So this impending relative motion is what is opposed by the static friction. Static friction is responsible to provide the box with the same acceleration as that of the train, so that this box remains stationary with respect to the train and there is no relative motion between the two. So what is the origin of this force of friction? When you look at the two surfaces in contact, the two surfaces in contact may appear smooth, but actually they are not that smooth as they seem to be. Friction appears because of the interaction of the charged particles of the two bodies near the surfaces of contact. Any polished steel surface or a glass surface would appear to be smooth, but actually it is not. If you observe these smooth looking surfaces under a powerful microscope, the surfaces are found to be quite irregular. When the two bodies are kept over one another, the real area in contact is actually much smaller. So at these points of contact, the distance between the particles of the two bodies, they become very small, and the molecular forces start to operate across the surface. So what happens is that at the points of contact, molecular bonds are formed. When one of the two bodies is pulled over the other bodies, these previous molecular bonds are breaking in this case, and new molecular bonds at the new points of contact are getting formed. Both these two surfaces are deformed. This local deformation sends vibration waves into the body. ये local deformation की वजह से क्या होगा? They send vibration waves into the two bodies, because deformation दोनों bodies का है और ये प्रोसेस दोनों के लिए हो रहा है. These vibrations as a result of all this will finally damp out and this vibration will appear in the form of energy. And this energy appears as the increased random motion of the particles of the body. जो constituent particles दो bodies को बना रहे हैं उनकी energy increase होगी. What will that result into? The two bodies thus become heated. As you can also observe in the case when you rub your both hands together. If you rub your hands vigorously, you can feel the heat. You can feel the heat. So, a force is therefore needed to start the motion or to maintain the motion. So that was all for today. I hope you liked my video. You can also follow me on Instagram. I'll be back with my next video. Till that time, do not forget to take really good care of yourselves. Bye bye.